Okay, so this is section 2.4. We're going to talk about complex numbers. This is the first time we're going to talk about complex numbers this year. We're going to come back to complex numbers and do some more interesting operations with them once we talk about vectors. And and this is not, however, the first time you have done complex numbers. This is something that you've talked about before. So everything we learned today is actually something that you have learned before. So I'll review. Okay, so what are complex numbers? They're numbers that help complete our number system. They're not real numbers. Real numbers are also complex numbers, but we're just going to add some numbers into the real number system to get the complex number system. Okay, and so what complex numbers are there for is one of the things they do is they will solve equations of the form what squared plus 1 is 0, or what squared is negative 1. And the number that's squared is negative 1 is the imaginary unit number, or the square root of negative 1 is what we call it. It is the square root of negative 1, and we use the symbol I for that. Okay, so complex numbers written in standard form are written as A plus BI. A is your real component, and B is your imaginary component. When B equals 0, we have a real number. Okay, so the first thing we're going to talk about is that I is the square root of negative 1, and so when you square I, you get negative 1. That was the whole point of coming up with I. It's the number that when squared is negative 1. So if I take I squared and I multiply that by I, then I get I cubed, which is negative 1 times the square root of negative 1, or negative square root of negative 1, or also negative I. Okay, and then I to the fourth would be 1, because this is negative 1 times negative 1, or negative 1 squared, which is 1. Okay, so those four basic operations, and then what happens is we cycle through these, because I to the fifth is going to be I again. That's I times I to the fourth, so 1 times I is I. All right, so we just have a couple of examples we're going to run through. It should be review. When two complex numbers are equal, then their real parts are equal, and their imaginary parts are equal. So in this example, find A and B so that these two complex numbers are equal. That means that 2A has to equal 2, so A must be 1. It also means that negative 3 minus B has to equal positive 4. So that means negative 3 plus B is 4, and so B is 7. Okay, next example. You can write a complex number in lots of different forms, but we always like standard form, which is of the form A plus BI. So you should see A plus, or a number plus a number I. So in this one, see how we have I squared? I squared is negative 1. So this is 1 plus 3I. And next on this one, you want to do the square root of negative 144. The square root of 144 is 12, and the square root of negative is I. Negative 1 is I. Now we're going to do these operations and then write the result in standard form. With order of operations, you need to make these into something I before you multiply the square roots, okay? Because it's in parentheses, and I want you to write this as otherwise you'll get B off in your sign. So this is negative 2 plus 2 radical 2I. And then this number over here is 5 minus 5I. No, 5 radical 2. Okay, and now to add them, you add the real parts, and then you add the imaginary parts. And over here in this example, I will leave this one for you to do. It's very simple. Just don't forget to distribute that negative and then collect like terms. Here we have some products that we're going to do. So again, I want you to start out by doing the square root of negative 1 is I. Do that first. So this is radical 10I times radical 6i. So that's radical 60i squared. I squared is negative 1. And the square root of 2, or 60, reduces to 2 radical 15, and then I've made my I squared a negative 1. Notice if you had multiplied first, you would get square root of 60, which is 2 radical 15, and you would miss this negative part here. So you want to do order of operations, which means you do the parentheses first before you do the multiply. So you think of a square root as a parenthesis and do the square root of negative 1 into I first. Okay, over here we're going to FOIL. First gives me 6. Outside gives me 8i. Inside gives me minus 3i. And then the last numbers, negative I and 4i, is minus 4i squared. Now at this step, we're going to collect like terms and convert that I squared into a negative 1. So this is now plus 4. And so my final answer is 10 plus 5i. I'm going to leave this one for you to do. Don't forget that FOILs. And then this last one, I want to point this out. These are called conjugates. They get a special name. I want you to see what happens when we multiply these. We're going to still FOIL. So I get 4 plus 2i minus 2i minus I squared. So what happens is in the outside and the inside term, they're canceling. And the only way that outside and inside terms cancel completely like that is when you have the same first and last in each of the binomial parts, in each of these terms, which are comprised of 2 terms. So, and except you have a difference in sign between them. That will get you an outside-inside cancel every time. And so this is 4 minus I squared, which is 4 plus 1. And so we actually got the real number 5. This is a complex number in standard form. It's just that the b is 0. Okay. So now we're going to really talk about that conjugate part. Complex conjugates are a plus bi, a minus bi. Okay, so the signs are opposite. Okay, in this example, 2 plus radical 3i, what's the complex conjugate of that? That would be 2 minus radical 3i. And now I'm going to multiply those together, and I get 4 minus 3i squared. When I multiply by complex conjugates, I don't bother to FOIL. I just FL, because I know the outside and the inside cancel. So this is 4 plus 3, and this answer is 7. Square root of negative 24. Let's write this in standard form first. So that is 2 radical 6 I. 2 radical 6 I. So a plus bi is our, so this is 0 plus 2 radical 6i. My complex conjugate would be 0 minus 2 radical 6i. And so when I multiply these together, I get 24 I squared, so negative 24. Oh, good. Then the next thing we are working on here is division. And division is the most tedious operation. It's not the most difficult, but it is a little tricky. You can't divide very easily because of the fact that this has 2 terms and it has that plus. There's nothing you can do to simplify here. It's strange, but to divide, we multiply. And I guess that's sort of a theme. When you divide by a fraction, you actually multiply by the reciprocal. So to divide by a complex number, you multiply by the complex conjugate, and you're going to do this in the numerator and in the denominator. And the reason why we do that is because now the denominator will be 1 minus 4i squared, which is just 5. And I can distribute something with just 1 term very easily. But with the 2 terms, the 1 plus 2i, there's no distributing that nicely. Okay, and then my numerator is 5 minus I times 1 minus 2i. And when I FOIL this, I get 5 minus I minus 10i plus 2i squared. That's going to be 5 minus 2, 3 minus 11i. And I'm just going to go ahead and distribute the 5. So 3/5 minus 11/5 I looks just like a complex number. Okay. Last few examples. So the whole reason why we have complex conjugates or complex numbers is so that we can solve quadratics perfectly. I don't believe that this factors, so I'm going to use the quadratic formula. Remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, you do need to know that. Okay, so 4 plus or minus, this is what t is going to equal, 4 plus or minus the square root of 16 minus 4ac, so that's minus 12 times 16. So 4ac is 192. All over 2a, that's 32. Gosh, this is some arithmetic, man. So 4 plus or minus the square root of, negative 176 over 32. And the square root of negative 176 is 4 radical 11. And then I'm going to go ahead and make the negative into an I. This is all over 32. I'm going to distribute my 32. So this is 1/8 plus or minus 1 radical 11/8 I. Lovely answer there. All right. Now, before I said that, I to the fifth is just I because we cycle through these three numbers, right? I is the square root of negative 1. I squared is negative 1. I cubed is negative I. And I to the fourth is negative 1. And so all powers of I are really just one of those four. And so how do you figure out what it is? Well, you figure out how it cycles. The cycle has a length of 4, so I'm going to take 4 into 79 and see how many complete cycles I get. So 4 goes into 7 once, 39, 4 goes into 39 9 times, 36, and I have a remainder of 3. This means that I cycle through I squared, I cubed, I to the fourth 19 times, and then the last time I don't go all the way through because I have a remainder of 3. Remainder of 3 means I land on an I cubed, so this equals negative I. That's your answer. All right, this last one is a good one. There are lots of different ways you can do it, and I'm going to leave that one for you to do.